So welcome you all. This is the session where I'm going to discuss basics of linked list, which is the concept of the data structure. So we are starting the session. First, let's see the definition of the linked list. The definition says it is a linear data structure because it comes under the type of data structure where two types are there, linear and non-linear data structure. So linked list is a linear data structure and it is a collection of nodes. So you can see in the diagram it's a collection of nodes where each node contains the pointer to the next node. So you can see in this node you have a pointer called next which is pointing to the next node. So each node has a pointer called next which is pointing to the next node. Hence it says which is a collection of nodes where each node contains a pointer to the next node. And the linked list is also called as a chain. So entire this list also is called as a chain. Okay, so chain means it is nothing but a linked list. The very important part is a node here. So I have shown in the diagram here, a node consists of two parts, data part and the next part. So what is a node? Node has two parts, data part. Data part is used to hold the actual data. You can have single data or multiple data in the data part. In our example, we are going to have a single part only. So data is consists of a single data. And the link part holds the address of the next node. So it's a pointer. Okay. So link part is a pointer, and that is how the node is represented as a two parts. Now when you create a node, if you want to create a node like this where we have data part and link part, then you have to write the structure. So you can see in the example type def struct link node. Inside this we have two parts, data part and the link part. Data part is integer, that means you can store an integer value in the data part, and the link part is a pointer to struct link node. Okay, struct link node is the same type which is defined above. So the pointer should be of the same type. So that means name of the structure should be the pointer type. And you have type def. Type def means what? You are giving another name, alias, to the entire structure as node. So node is alias. So you can see this node represents data part and the link part, and this is called as a node. So this node, that is what we are going to use in creating the pointers or variables. For example, how will you create a pointer for this node? We'll simply say node star p. Node star p means p is a pointer of this type structure. Okay, where you can create data part in the link part. Right now, it's simply a pointer. Now let's see the code. How can you write the code on this structure? First, node star p. When you say node star p, it's simply a pointer called p, and initially it will have garbage address. So pointer means it can hold only address. So there is no node. Right now, we have no node. So to create a node, you have to use a new keyword. New keyword dynamically construct the node. So how to construct the node? You will say p equal to new node. Node means it is the size of the structure. Okay, node will be replaced by the size of the structure. What is the size of the structure? Data part takes 2 bytes and generally the link part takes 4 bytes. So there will be 6 bytes of memory will be allocated and the address will be returned to p. That means somewhere in the heap, okay, in the heap somewhere a node is constructed. Assume the node is constructed at the address 100. Okay, 100 is the address. So whenever the new node is constructed using new node, the address of the node is returned to the variable here where you are saying p equal to. So it is returned to p. So p will get that address 100. So what does that mean? This means p is pointing to the node whose address is 100. So p is pointing to this node. Okay. Now you want to store a value 10 in the node. So how will you store value 10 in the node? So value can be stored in the data part. So how to access the data part? You have to use this p, use this arrow and say data. So p arrow data should be changed with value 10. So how will you write that? So you can simply write p arrow data equal to 10. So this data part can be accessed by saying p arrow data. Link part can be accessed by saying p arrow link. So p arrow link means you are accessing link part. P arrow data means you are accessing the data part. So this data part you are writing 10. So this data part is written with 10. So you got here 10 value because it's integer data. Okay, so 10 is written. So that is how you can modify the node or you can access the elements of the node. Now generally we say p equal to get node whenever we want to create a new node. So we are going to write this code henceforth. So we'll write always pointer equal to get node. Okay, any pointer name you can use. Here I have used p equal to get node. So what does that means? Get node is a function which is responsible to create a node in the heap. So I have shown the function here. So this is how the function will look like. So get node is a function and its return type is node star. That means you're returning the pointer to the newly constructed node. Then the first line in this, okay, so this function call get node is calling this function. When you say p equal to get node, a function is called here, and you will come to the first line. First line is node star temp. That means what you are creating the temporary pointer for the node. So same temporary pointer is created here for the node, and then you are saying temp equal to new node. So what is meant by temp equal to new node? You are constructing the new node and the address of the new node will be returned to temp. So somewhere in the heap, a node is constructed. Suppose at address 100, the node is constructed. So its address is returned to temp. So temp will get that address. So what does that means? So temp is pointing to the node whose address is 100. So it is pointing to this node. So temp is pointing to this node. That's why it is storing that address of that node. Now next, temp arrow link equal to null. So what is meant by temp arrow link? So this is your temp, this is arrow, and this is your link part. So this will change to null. You are assigning null to that temp arrow link. So this is a link part. This link part can be accessed using the temp by saying temp arrow link. So this link part will become null. So you have written null here. So generally the pointer should be set to null. Then you will say return temp. So what will happen? Return temp. Return temp means it will come back to the calling function. So it will come back to p. So that temp will be returned to p. That means temp is returned and it is copied to p. So that means what? This temp value is copied to this p. So p will have the same value. Temp value is copied to p. P has the same value. That means p is also pointing to the same node. Okay, p is also pointing to the same node. And when you come out of the get node function, what will happen? The local pointer will be destroyed. P is not local here, only temp is local. So temp pointer will be destroyed here. So you can see P is pointing to the newly constructed node. So now onwards, you just remember whenever we say P equal to get node, a new node is constructed and its address is returned to P. So P will be holding that address of the new node and P will be pointing. So if you say your temp equal to get node, then temp will be the pointer pointing to the new node. Okay, so here get node is a function we are going to use again and again. So this line you remember. Whenever you say P equal to get node, a new node is constructed and its address is returned to the variable that you used here. Now get node is modified a little bit. So in the get node, you can see one if condition is added. So what is the use of if condition? Whenever you create a new node using temp equal to new node, there is a chance that node is not created due to some reason. Maybe stack is full or some other reason the node may not be created. In that case, the temp will be null. Okay, temp will get null. Then you are checking is temp null, that means node is not created. So will display the error message. You can say node not created or not enough memory. Some error message you display and exit the program. You cannot continue. You have to exit. Okay. Otherwise, the rest of the code will remain same. Now we will come to the types of the linked list. So we have four types of the linked list: singly linked list, circular singly linked list, doubly linked list, and circular doubly linked list. So we are going to discuss only singly linked list in this session, and only one of the operation on that we'll discuss in this session. So what is singly linked list? In the singly linked list, you will have multiple nodes where each node will be pointing to the next node and the last node is pointing to null. Whereas there is one extra pointer used called as a start pointer. It is also called as external pointer, which will be pointing to the first node. Okay. So you can see external pointer start points to the first node and the last node contains the pointer to null. Last node contains the pointer to null. Whereas each node will be pointing to next node. So this type of a linked list is called as a singly linked list. The singly linked list can be also viewed like this, where you have data part on top and the link part in the bottom. And this link part is pointing to the next node. So next node also same way. And last node is having null, and start is pointing to the first node. So this is another view of the singly linked list. Now assume we have three nodes. First node is created at the address 100. Second node is created at the address 200, and third node is created at the address 300. And they are storing the data also. First node is storing 10, second node is storing 20, third node is storing 30. Now you have to make this start pointer point to the first node. So if this link has to be created, what should be the value of start? The value of start should be the address of the first node. That means 100. So if you write 100 here, then the start will be pointing to the first node. So one link is created. Now the first node should point to the second node. So what should be the value of this link part? So value of this link part should be the address of this node. That means this 200 should be here. Then this will be pointing to the next node. So write 200 here. So if you write 200 here, this node is pointing to this node. Now second node should point to the third node. So this link should be changed. So this link should be the address of the next node, that is 300. So write 300 here. So it is pointing to the next node. Now this is the last node. This should not point to any other node. So the link path should be null. So it is not pointing to any node. So this is how the addresses are stored in the pointer link part, and data part will hold the values, and every node has its own address. So this is what you have to understand, and how the start pointer points to the first node. Once you understood this concept, then next part becomes very easy for you. So once you understood this concept, now we'll see the primitive operations that can be performed on the singly linked list. So primitive operations are inserting a node into the list, deleting a node from the list, searching an item in the list, and traversing a list. So we have generally four primitive operations. So we'll discuss the first one, that is inserting a node. Inserting a node has many options you have. You can insert a node in the front or in the beginning. You can insert a node at the end, or you can insert at a given position. You can insert a node at a given position, or you can insert after a given key. A node can be inserted after a given key. So we are going to discuss only the first function today. So this is the code for insert front, where there is an input called value, and this you are creating a node for this value, and that node will be inserted. So that node will hold this value that is going to input. So first line creates the new node. Second line copies the value to the data part of the node. Third line creates the link between the nodes, and the last line, the start pointer, will always point to the first node. So insert front means every node should be inserted in the beginning of the linked list. Every node inserted should be the first node. And we have taken the first case. If the list is initially empty, then what is the value of start? Value of start will be null. That means there is no linked list exist. So this is the initial condition. We will have start pointer null. And suppose we call the function by saying insert front of 30. That means we want to create a node with value 30, and that should be the part of the linked list. So when you call the function insert front, this function is called, this 30 is copied to val, so val becomes 30 here. Then it enters the function. So this is the first line of the function. It says node start temp equal to get node. So already you know what is get node. Get node will construct somewhere in the heap a new node. So assume the new node is created at some address 300, new node address 300. So get node will create the address, create the node at some address, and that address is returned to temp. So temp will hold that address. So here we have temp variable, this temp will hold that address. So temp is storing 300 here. That is the address of the new node. So temp will be pointing to the node. So this is what happens in the first line. Temp equal to get node. Get node creates the new node, and its address is stored in temp. So temp is storing the address of the new node. Okay, so that is what the first line. So each time get node means it is creating a new node. Then we'll enter the next line. So next line says temp arrow data equal to val. That means what? You are using this temp pointer and you are accessing the data part. So how to access data part? Simple, temp arrow data. So temp arrow data equal to val. That means this data part you are changing with val. What is val? Val is 30, which is already passed. So this data will become 30. Okay, val is 30 here. So data part becomes 30. You can see data part changed to 30. So temp arrow data will be 30. So here temp arrow and data. Then we'll go to the next line. Temp arrow link equal to start. So what is mean by that? Temp arrow link equal to start. Now understand the start first. What is start? Start is nothing but it is having the null. Okay, so we get null. This null is copied to temp arrow link. So what is temp arrow link? This is your temp, this is your arrow, and this is link. So this link will change. So this start value is written here to the link part. So start value is written into the link part. So that is what the meaning of this line. Okay. So what value will come here? This null value will be written here. So this is written by null. Okay, this value changes to null by this code. Then it goes to the next line. What is next line? Start equal to temp. What is meant by start equal to temp? You're copying the temp value to start. Okay, that means temp is having 300. This value you're copying to start. So we'll copy here, okay, into the start. So that means what will be the value of start now? Value of start will be the same value of temp, that is 300. So when 300 comes here, that means start is pointing to the node whose address is 300. So this is the node whose address is 300. So start is pointing here. So you can see a new node is inserted and the start is pointing to that new node. When you come out of the function, that means entire function is finished, then local pointer will be destroyed. Local pointer is the temp pointer. So this temp pointer will be destroyed. So you can see the new node is inserted in the linked list. Now linked list has only one node where start is pointing to that node and this is the first node. Now say we call the function once again but changing the value by changing 40 now. We are calling the same function again by changing the value to 40. So what will happen? Again the same function is called. Now val will become 40. Okay, val becomes 40 and it enters the function. Get node, again what this is the get node will do, creates the new node and its address is returned to temp. So in the heap again somewhere the new node is created and its address is returned to temp. So temp is pointing to new node. So this is what happens in the first line. New node is constructed, temp is pointing to the new node. It enters the next line. Temp arrow data equal to val. So what is temp arrow data? So see temp. So you have to start from, you have to access the data part. How to access the data part? Use temp and use this arrow. So temp arrow data is this one. So that will be the val. What is val? Val is 40. So the value changes here. This data changes to 40. So you see 40 has come here. Okay. Then it enters the next line. Temp arrow link equal to start. So what is temp arrow link? So again access now what is temp arrow link? That will be changed with start. So start is what? Start is 300. So this 300 is copied to temp arrow link. So this temp arrow link, this is temp, this is arrow, and this is link. So the start will be copied into this link part. Understood? So we are copying this start into this link part. Okay, the start is copied to link part of temp. Temp is pointing to this link. Okay, so this link part will change with start. That means what 300 will come here. Okay, so what will happen if the 300 comes here? Okay, if 300 comes here, this node is pointing to the node whose address is 300. So this is the node whose address is 300. So this node is pointing to the node whose address is 300. So link is created. Okay, link is created. Now this node should be the first node because the function is insert front. This should be the first node. So next line, what it does, start equal to temp. Start equal to temp means what? Temp value is copied to start. So what is temp value? 200, that is copied to start. Okay, so this temp is copied to start. Correct. So temp will be get copied to start. So this start 300 will be replaced by 200. So value changes. Start value changes. So it becomes 200. So 200 means what? It is not pointing to this node now. It is pointing to this node because this node address is 200. So start is pointing to this node. So when you come out of the function, the temporary pointer will be destroyed. So what did you observe here? The new node was the node with the value 40, and it is the first node in the linked list now. It has become first node. That's why it is insert front. Is it clear? So that is how it works. So I will end up here, and I will give you students homework. You trace this function once again for this value. I will take this value, insert front of 50. So that means one more node is inserted with the value 50. Trace this code and see how the links are created, how the node is created, how the links are created, and how it becomes the first node. Trace this code, and then we will discuss in the next session. We will discuss the next part of this, how to how the third node will get inserted. So trace it. We'll meet you in the next.